Hi, and welcome to this section of the Matrix Algebra Tutor. And in this section of the class, we're going to tackle the topic of the determinant of a matrix. Okay, so we learned about the inverse of a matrix, and that was a useful concept when we were trying to solve systems of equations to kind of cancel terms, so to speak, and solve the system, right? Determinant is one of those things that's very useful for other things outside of what we're learning about today, but also you'll learn in the next section, after I teach you how to calculate them, in the next section we'll use determinants as yet another way to solve systems of equations. So this whole course really is about solving systems of equations using matrices, different methods of it, okay? So let's learn about the determinant now, and we'll learn about the application of what to use it for in the next section, okay? Now the main thing between a determinant and an inverse, to keep them straight in your head, inverse is a matrix. You get an inverse matrix. When you calculate a determinant, you're always going to get a number, just a number. That's all. You get a matrix, you're going to do some math in there, and you're going to get a single number back. The determinant might be 3, or the determinant might be -5/7, or the determinant might be -9 or something. But your determinant is going to be a single number, okay? So let's go ahead and do that. The easiest way to do this is just to show you and just start banging through some examples and show you what a determinant is and how to calculate that. So first, we're going to start with the determinant, which I'm going to abbreviate DET. You'll usually see it in the books like that, determinant of a 2×2 matrix, which is just a simple little square matrix. And then we're going to practice that, and we're going to go on and do the 3×3s because that's going to be a little bit more involved. But we need to master the 2×2s first. So one thing at a time. And you'll see that it's not, this is, compared to doing an inverse, the determinant's not very hard at all, okay? So you have a matrix, A, B, C, D, okay? A, B, C, D. All right, and the determinant is usually written with a DET out in front, telling you it's the determinant, or sometimes you'll actually just see these little vertical bars, A, B, C, D, to calculate the determinant, okay? Either way, it's just notation. The determinant's actually calculated as follows. What I need you to do is envision an X here, an X going from left to right, upper left to lower right, and then like this. You need to remember that like this. Just draw an X with your fingers. That's the determinant, and you'll see why. A times D minus B times C. That is the determinant. That's it. There's no matrix involved. There's nothing to multiply by. That's it. AD minus BC. That's it. So that's why the X is very useful for you. AD minus BC. That's why instead of memorizing this, people in their book, they'll see this and they'll try to memorize it. Is it A times D, or is it A times C, or whatever? Well, that's fine. Don't memorize that. You know, we're much better at looking at patterns. Just look at the square and draw an X, just like you would in the alphabet, and you'll know how to take the determinant. It's not that hard, okay? That is how you calculate it, so let's go ahead and do a few. If I were going to find the determinant of the matrix 2, -7, -3, 4, how would I do it? Well, I'm not going to memorize this. I'm not going to label A, B, C, and D. I'm going to put an X with my fingers, literally. 2 times 4 minus this direction, -7 times -3. That's it. 2 times 4 minus -7 times -3. You must put the minus there or you're going to get the wrong answer, okay? So 2 times 4 is 8 minus -7 times -3 is positive 21. And you'll find that 8 minus 21 is -13. This is the answer. So you see it's a number, -13. That is the determinant of this matrix. Now I haven't told you why it's useful. I haven't told you what it's used for. But I will tell you that matrix determinants have application far beyond solving systems of equations. When you get into advanced calculus and other things, these determinant things pop up over and over again. But once you start dispensing with memorizing letters, it's pretty easy. Just draw an X like this, okay? Now the next one, let's say I wanted to find the determinant of -6 times 7, -1, and 4. I'm sorry, I think I may have said -6 times 7. This is a matrix, -6, 7, -1, 4. If I want to find the determinant of that, so in order to do that, we're just going to visualize an X. We're going to go this direction, then we're going to go this direction. -6 times -4. I'm sorry, -6 times +4, minus, and then going this direction is 7 times -1. Okay? Going like this, then going like this. 6 times 4 is 24, so it's -24 here, minus 7 times negative 1 is negative 7. So you're going to have negative 24 plus 7. So at the end of the day, negative 24 plus 7, you're going to have negative 17. And that is the determinant. So you see, again, you arrive at a number. You don't arrive at anything complicated. So compared to finding the inverse of a matrix, this is actually very simple. Okay? Let's go ahead and do another 2 by 2, and then we'll go off and talk about how to do more complicated problems. Okay? If I were going to find the determinant of 5, negative 6, negative 2, and 8, again, I wouldn't memorize letters or formulas. I would just draw an X, like this, and then like this. 5 times 8 minus this direction, negative 6 times negative 2. Okay? 8 times 5 is 40, minus 6 times 2 is 12, but it's negative times negative gives me a positive, so it's going to be positive 12 here. Okay? And 40 minus 12 is going to be 28, and that's going to be the answer. So that is the determinant of that matrix there. So determinants of 2 by 2 matrices aren't very hard. You just have to remember to do this X thing. The reason why I'm trying to beat it into your brain to remember how to do that little X is because when we do the 3 by 3, which I'm going to teach you right now, you're still going to have to use that, but you're going to have a few other steps involved. It's not going to be a big deal. Let's go ahead and do that right now. Okay, now if you were going to find the determinant of a matrix of a 3 by 3, A, B, C, D, E, F, G, H, I, your book is probably going to have a very long formula or something for you to remember. I don't like to teach determinants that way because it's useless and you're never going to remember it. Okay? This is how I take determinants every day of the week when I do it, and I've never forgotten after all these years how to do it. You get a little practice and you won't forget either. Okay? First thing you do is you have to go row by row. Okay? So what I want you to do is I want you to put an A down. We're going to get the hang of this by example. Okay? Because we wrote the letter A down, I want you to mark out this column and mark out this row because A is in both of those guys. So we're marking out this and marking out this. So it's A times the determinant of whatever is left over here. So it's the determinant of E, F, H, I. Okay? So again, you put the A down and you mark out these rows because you've done that, and now you take the determinant of what is left over. And that's what's here, A times the determinant here. Now these little bitty determinants of 2 by 2s are very, very simple to calculate. We've just done that, okay? Now, we've done A. Now let's put B down. But this is the only thing you really have to remember. You have to put a minus here for that middle term. And I'll just beat it in your head as we go along, but you have to put a minus B. Now because you put B down, you mark out this row, and you mark out the center column because B is common to both of those. What you have left are these 2 letters and these 2 letters because this is gone and this is gone. So you need to take the determinant of whatever is left over. Okay? Multiply by D, F, G, I. Okay, it looks complicated. It's not going to be that complicated, okay? We marked out B, we took the determinant of what was left over, and then you can add plus C, mark out this and this, take the determinant, the 2 by 2 determinant of what is left over here. D, E, G, H. This is how I take determinants, and once you do it a few times, it will not be very hard because this, taking the determinant of the 2 by 2 is going to become second nature after a while. All you need to remember is just hold your pencil over these columns, mark them out, take the determinant of what's left over. For the middle one, write it down with a negative sign, take the determinant of what's left over. For the third column, write it down, take the determinant of what's left over. This stuff, add all of it together, that is the actual determinant of the entire matrix. So you can see that taking the determinant of a 3 by 3 is nothing more than taking determinants of little bitty matrices on the inside, basically, okay? So let's practice it with real numbers. And I think you will see that it's, you know, you have to pay attention to what you're doing, but it's not nearly as complicated as finding an inverse. If I wanted to find the determinant of the matrix 3, 0, 0, 2, 1, negative 5, 2, 5, negative 1, how would I proceed? Okay, so the way in which you proceed is exactly how we told you about before. You start with the first number, 3. You write that number down, 3. Because you wrote that one down, you mark this column out and you mark this row out, and the only thing you have left are these things here, so you take the determinant of that. 1, negative 5, 5, negative 1. Okay? You have to do that. We're going to do that in a subsequent step. Now you're going to move on to the next guy. you put a 0 down, but for the middle term, you always have to put a minus sign. You mark through this column, you mark through this row, this is left over and this is left over, and we have to take the determinant of that as if it were a 2 by 2. 2, negative 5, 2, negative 1. Okay? And then finally, for the third thing, we have a 0 here, so we're putting a 0. Okay? 0 here, we're marking through this column, we're marking through this row. This is what is left over here. 2, 1, 2, 1, 2, 5. Okay, now one thing I want to just stop and tell you is that just like the inverses, you are not expected to look at this and say, oh, that makes sense, that's a determinant. Of course not, okay? This is something that someone proved. This is something that some very smart mathematician went through and figured out that if you do this, this gives you a determinant of a 3 by 3 matrix. It's not something that you're going to just remember, okay? Or that you're just going to know just by looking at it. But with practice, you'll remember. Now, you could calculate this determinant and get a number, but since you're multiplying by 0, this entire term is going to be 0. You could calculate this determinant, but since you're multiplying by a 0, this one happens to be a 0. So really, the only thing you have to do calculation-wise is this one here. Okay, so what you're going to have here is 3. On the inside, you need to take the determinant of this. So you do your x, just like this. 1 times negative 1 minus, going this way, like this, negative 5 times 5. Okay. That's it, and you're multiplying by 3 because that's what's on the outside. So on the inside you have 1 times negative 1 is negative 1, 5 times 5 is 25, so you have negative 25 times negative is positive 25. Okay, so what you're going to have is 3 times 24. Okay, 3 times 24, so what you're going to have is 72. That's the determinant of the matrix. We're going to do a few more of these, so if it doesn't quite make sense, you're going to get more practice, but basically what you do is you always start with the first one, you write it down, take the determinant of what's left over after you mark through this and this, okay? Write the second number down from the top here, take the determinant after you mark through this row and column of this guy here. That was what we were trying to do there. Same thing here, we take the determinant of what's left over, which is down over here. Now, because these were zeros, it turned out to be very simple, and that's why I chose this problem this way, so you don't get bogged down in math for your first example. So it turned out that this actually was all 0, and all you had to do was this. If this was non-zero, then you'd have to do this determinant thing a few more times and add up some numbers, and you would get the final answer. In this case, the determinant of this matrix is positive 72. Okay? So let's go ahead and do one that's a little bit more complicated. Okay? If I were going to take the determinant of 3, 1, 0, negative 3, 4, 0, negative 1, 3, negative 5. Okay? I want to take the determinant of that. How would I do that? Okay? Well, I start off and I write the first letter down. 3 times the determinant. I take and mark through this column, mark through this row. These 4 numbers are the only thing that's left, so 4, 0, 3, negative 5. Okay? That's all that's left over. Next thing I do is I write a 1 down, but for that middle term I have to put a negative sign there. That's just something you're going to have to remember. So it's negative 1. I mark through this row and I mark through this column, and the only thing that's left are these numbers over here, so I write those in. Negative 3, 0, negative 1, negative 5. Plus, the third column is a 0. That's going to end up being very easy for us. You mark through this column, mark through this row, and all I have are these 4 numbers down here, so I write down negative 3, 4, negative 1, and 3. Okay? So now I have everything I need. Now notice, though, right away, that because this is a 0, this whole term is just going to go to 0. I could calculate that determinant there, but I don't actually need to. So I'm going to put a 0 there. Now let's continue. What I'm going to have here is 3. Now I've got to calculate the determinant here with my x. 4 times negative 5 minus, going this direction, 0 times 3. Okay, I'm done with that term. Okay, because I've calculated the determinant on the inside. I need to do the math, but I've written it all down. Minus, and then over here, using my x, negative 3 times negative 5 minus 0 times negative 1, like this and like this. And that's it. Okay, so it just reduces down to some multiplication. So I'm going to have 3, and on the inside, 4 times 5 is 20, so negative 20. minus 0, so I can put a 0 here. Really, I don't need to. And then over here, I'm going to have 3 times 5 is 15, negative times negative is positive 15, and again I'm going to have minus 0. So really what I have is, so what I'm going to have here is I'm going to have 3 times negative 20 minus 15, okay? Because this is a term and this is a term, okay? 3 times negative 20 is negative 60 minus 15, right? And negative 60 minus 15 is negative 75, and that is the determinant of this matrix. So we start off with the matrix and we just go, column by column, putting the number in front. Whatever's left over, we take the determinant. For the middle one, we have to put a negative, take the determinant of what's left over. The third column, take the determinant of what's left over. We would do them all individually. This one happened to be 0 because of the 0 out in front. Do all the multiplication and you get a determinant. Okay, now let's do a couple of additional. Let's say you have 1, 1, 1, 2, 2, 2, and negative 3, 4, negative 5. We want to find the determinant of that. So we start with the first column. We're going to have a 1. We're going to take the determinant. We're going to mark through this column and this row. This is what's going to be left. So we're going to have 2, 2, 4, negative 5. Now for the middle term, you always have to have a negative, and this is a 1, so a 1 comes along for the ride. The determinant, after you mark through this column and this row, is going to be this stuff here. So you're going to have 2, 2, negative 3, negative 5. Okay? This is what you're going to have right there. And then for the third one, you're going to have this 1 here. So you're going to have a 1. You're going to mark through this column and this row, and all you're going to have left is over here. So you're going to have 2, 2, negative 3, and 4. And that, you're going to have to take that determinant. So you have to take 3 determinants in general to find a determinant of a 3 by 3 matrix. So what you're going to have is, since it's just multiplied by 1, you just kind of take this determinant, which is going to be going like an x, 2 times negative 5 minus 2 times 4. Okay? That's going to be this one. Minus the one here, which is like an x, 2 times negative 5 minus, going this direction, 2 times negative 3. Okay? That's going to be that one. And then the third one I'm just going to write down underneath, plus this one right here, going like an x, 2 times 4 minus 2 times negative 3. Okay? That's all you're going to have. So you're just basically reducing it to a bunch of multiplication. So on the first one, 2 times negative 5 is negative 10, minus 2 times 4 is 8, minus sign from here. 2 times negative 5 is negative 10, minus a negative 6 from this multiplication, so plus 6 over here. And then this one is going to be 2 times 4 is 8, minus 2 times negative 3 is negative 6. Negative 6 times negative 1 is positive 6. So we have 8 plus 6 over there. Over here, you're going to have negative 18. Okay? Over here, on the inside, you're going to have negative 4. And over here, of course, you're just going to have 8 plus 6 is going to give you the 14. So what you're going to have is negative 18. Negative times negative gives you positive 4 plus 14. So you can see right away that the 4 plus the 14 is going to give you the 18. 18 plus negative 18 is just going to give you a 0. Okay? It's just going to give you a 0. And that's the actual determinant of this matrix is 0. Okay? Okay, for our last one, we're going to have a 3 by 3. 1, 2, 3. 2, 2, negative 3. 3, 2, 1. And take the determinant of that. Okay? And the way I'm going to do it is I'm going to start column by column. I'm going to put a 1 here. I'm going to take the determinant after I mark through these guys of whatever's left over, which is this. 2, negative 3, 2, 1. And for the second term, you have to put a negative sign. I'm going to put this 2. The column here is headed by the number 2, so that goes there. The determinant that goes here after I mark through this and this is going to be these guys here. So 2, negative 3, 3, and 1. And for the final one, you're going to have a 3 here And your final determinant after marking through these are going to be all this over here. So 2, 2, 3, 2. 2, 2, 3, 2. Okay, so now I just have to take some determinants. Over here I'm going to have, marking like an X, 2 times 1 minus, going this direction, negative 3 times 2. Minus 2 times, going like an X, 2 times 1 minus, going this direction, negative 3 times 3, like that, okay? And then for the final one, I'm going to plus 3, going like an X, 2 times 2, minus, going this direction, 2 times 3. Okay, so now it's just a bunch of multiplication. On the inside here, 2 times 1 is 2, minus a negative is going to give me this positive 6, okay? Negative from here, 2, and on the inside, 2 times 1 is 2. Negative times negative gives me positive 9, plus 3 on the outside from here. 2 times 2 is 4, minus 2 times 3 is 6. Okay? Okay, 2 plus 6 is 8, minus 2 times 9 plus 2 is 11, plus 3 times, and on the inside, 4 minus 6 is going to give me negative 2. And finally, just finishing it up, you'll have 8 minus 2 times 11 is 22, minus 2 times 3 is 6. 8 minus 22 minus 6. So what you're going to have here, just to kind of do it in your head, 8 minus 6 is just going to give you 2 minus 22, just combining these guys. 2 minus 22 is just going to give you negative 20. So that determinant is negative 20. So basically, you just, when you're doing the 3 by 3 matrices, you have to go column by column and use the heading, the top of the columns, as sort of the coefficients out here, taking the determinants of what's left over. Now you have to make sure that you put a negative sign there because that's just the way it's derived. I didn't show you why, I'm just telling you that that's the case. So of course you can take determinants of 4 by 4s and 5 by 5s and 6 by 6s. And there are formulas that might be listed in your book to do that, and you can do it. It's just a bunch of math you could do. But it's not terribly intuitive in general when you start getting up into the 4 and 5 by 5 matrices. You're probably going to end up using a calculator or a computer to calculate it anyway. But try to remember this little trick here for determinants, because later on when you get into math, maybe on into some more advanced stuff in physics and calculus, when you start talking about vectors and cross products of vectors and things like that, this is going to be basically how you're going to calculate those things. Don't want to give too much of it away, but when you get to those advanced courses, this little technique of determinants is going to come back to be very useful when you're calculating some other more advanced things in calculus and physics and on from there. So that's a good introduction of how to calculate determinants. In the next section, we're going to apply that to actually solving some problems and solving some systems.